Conditions for aldol condensation reaction. It takes place in presence of dilute alkali and alpha hydrogen. At least one of the carbonyl must have alpha hydrogen. So now we will understand what is alpha hydrogen. For better understanding of this concept, let's take a simple example, CH3CHO. CHO is a functional group. Carbon next to functional group is alpha carbon. So this carbon is alpha carbon. Hydrogen attached with alpha carbon are known as alpha hydrogen. So here we have these three are alpha hydrogens. Let's take more example for concept clarity. Like in this example, CHO, a functional group. Carbon next to the functional group is alpha carbon, and these are alpha hydrogens. So in this compound we have two alpha hydrogen here. Let's switch to next example. Again the concept same. Carbon next to the functional part. This carbon is alpha carbon, and the hydrogens belonging to this alpha carbon are alpha hydrogens. So whatever the chain length may be, we simply focus on alpha carbon only for aldol condensation reaction. So let's take the next example. CHO, functional part, alpha carbon, and the hydrogen belonging to this carbon, that is a alpha hydrogen. So in this compound we have one alpha hydrogen here. Next example, CHO, functional part. Carbon next to functional part is alpha carbon, and hydrogen belonging to this carbon is alpha hydrogen. So in this compound we have two alpha hydrogens. Now in these cyclic structures, this carbon is a functional carbon, and carbon next to this functional carbon, like these two, are alpha carbons. So here we have two alpha carbons, both are identical, and the hydrogen belonging to these alpha carbons are alpha hydrogen. In next example, functional part, alpha carbon, alpha hydrogen. In this structure, functional part, carbon next to functional part, alpha carbon, and it contains one alpha hydrogen in it. In this structure also, we have two alpha carbon. This one is alpha 1, let's label it alpha 1, and this carbon, we label it alpha 2. Alpha 1 contains 3 hydrogens. So here we have 3 alpha hydrogen in this compound. But the carbon of benzene ring, this carbon, it doesn't have any alpha hydrogen. So here we have alpha carbon having no alpha hydrogen. Alpha hydrogen is absent here. An important question usually asked from this topic, like so many compounds are given to you and you have to identify whether these compound they undergoes aldol condensation or not. For this you have to recognize or check on whether a particular compound contains alpha hydrogen in it or not. If the compound contains alpha hydrogen, then it will show aldol condensation reaction. So let's check. In first example, functional part alpha carbon, so it definitely show aldol condensation. In next example, functional part it doesn't have any alpha carbon, neither alpha carbon nor alpha hydrogen is there, so it doesn't show aldol condensation reaction. In third example, functional part alpha carbon along with alpha hydrogen, so it definitely shows aldol condensation. Switch to next example. Functional part with alpha hydrogen, it also shows aldol condensation. Next, we have alpha carbons here, but the carbons do not have alpha hydrogen. So this compound, it doesn't show aldol condensation reaction. Switch to next. Again the same type of, we have functional part alpha carbon but no alpha hydrogen, so no aldol condensation visible here. Next example, functional part alpha carbon, so aldol is possible here. In this compound we have functional group alpha carbon but no alpha hydrogen here again, so it doesn't show aldol condensation. Last but not the least, functional part it has alpha carbon, so it shows aldol condensation reaction.